What's up friends, in this video we're going to be finishing off the $500 electric mountain board build. Let's jump right into it.
Make my heart beat super fast.
Alright, welcome back. This is going to be the second to last video in this build series for the electric mountain board kit. And in this video we're going to be installing all of the enclosures onto the deck with some threaded inserts, insulating everything to prevent some road vibrations, and then we're going to turn it on and make sure it works properly. The next video of this series I'll be giving some first riding impressions and a total price breakdown. Spoilers, it's not $500. Alright, so in the last video of this series we built the beautiful battery for this board. With that, I connected all of the BMS wires, I welded all the cells together, and got it all completely finished. If you haven't checked that out yet, go ahead and check out the video in the iCard. Now, if I were to just put these batteries right into the enclosures, they would start rattling around the second I hit any kind of road. So we'll have to secure those in this video. But first, we'll need to secure all of the enclosure segments onto the deck with some threaded inserts. Let's hop right on it. Threaded inserts are a super common piece of hardware that's used to mount electric skateboard enclosures to their decks. And the main reason for this is because they look really clean. From the top, you can't see any weird markings on the grip tape or bumps, and from the bottom, it looks like they're just going straight into the wood. So for this board, we're going to be using some threaded inserts as well, and there's a lot of different ones to choose from. There's coarse thread ones, there's press fit ones, there's rivet ones, but today we're going to be using some Easy Lock M4 inserts, and these are made of brass and are 3/8 of an inch long. These should fit nicely into this deck, and I've used them with great success in the past. I'm going to show you guys a pretty cool trick on how to insert these into the deck, and we'll get moving. Before installing the inserts into the deck, we're going to need to drill all of the holes. To do that, I'm going to be using a 1/4 inch bit, which is one step smaller than the 17/64 that they recommend, just because I want a little bit extra room. Now, in order to mark out all the holes on the deck, I'm going to need to lay out all the enclosure segments and kind of tape them in place, and then center punch all of the holes to make sure that I'm going to put them on correctly. So we'll do a little time lapse right now, and I'll go ahead and mark out all of the hole locations. Originally, I was intending to use the center punch to mark all these holes onto the deck, but it ended up not fitting through the extra space for the screw head, so I chose to use a smaller drill bit on my drill and just lightly tap each spot, and that worked out perfectly. Alright, so I've just started to drill out the holes, and I've got my 1/4 inch bit with the tape set to approximately the depth of an insert. I made it just a little bit shorter so that I can account for the tip, and once I screw in the first insert, then we'll know exactly how long to make it, and I can readjust where the tape goes. And I haven't started mixing it yet, but I've got my epoxy here as well, and I'm going to mix this up, and then we'll get to installing the first few inserts. Alright, so I got my epoxy mixed up, and I've got a couple inserts installed that I did just ahead to make sure it was going to go smoothly, and now it's time to actually install them. So what you're going to want to do is get your drill ready, And I'm gonna make this little assembly. So this assembly that I make is just a extra long screw of the same exact threading. I think this is an M4 by 30. And what I do is I stick a single nut onto the screw, and then I rotate it and put it all the way at the head, and you can just finger tighten it. And then the next step is taking a threaded insert, and you're going to put the slotted side towards the nut and just screw it all the way down. Now you have this little assembly, and you're going to take this and stick it right into the drill. So you should be able to get the nut, the flat face of the nut, to attach to your tri-finger chuck, and you know you did it right if it doesn't wobble too much. So it looks like mine wobbles a little bit, so I'll just loosen it and straighten it out. There we go. See, it runs true with the drill. And now it's time to actually install it. So what we're going to do now is take another insert, and we're just going to screw it onto the exposed threads, and you want the slotted side to face down into the hole, and you just screw it on. It meets the other insert, and now you can apply some epoxy. Just going to put a little bit around the edges, and this is just standard JB Weld steel formula, and you just want to put a little bit on there to help your insert stay in the hole. This is optional. Some people swear by it, some people don't. I think it's a good idea. My last board that I built has threaded inserts with epoxy and they haven't budged, so I figure it's a good method. Now, we're just going to take the drill and we're going to make sure that the drill is upright and that the threads are going to match the angle of the screw that comes through the enclosure. So we're going to just do this, give it some firm pressure, make sure we're in the torque speed mode on your drill, and slowly screw it in. That looks like it's about right. And you can see there's a little bit of a glob of epoxy there. And we can just scoop that around to the other side. Now, your mileage may vary on if your wood around the insert will split. Sometimes that can happen. Don't worry about it too much. But if it looks like it's really falling out, then you might want to consider drilling your hole out a little bit bigger or just loosening up a little bit. But since I've got epoxy in there, I don't really have to worry about it too much, and it doesn't look like it split very much at all either. So there's one installed, and now I gotta do 17 more. So I'm gonna get on that, and you guys can watch a quick time lapse. So here you go. Alright, so I've let all of the inserts dry overnight and all the epoxy is completely hardened, and I did a quick test fit on each of the different enclosure spots, and I actually did a really good job keeping the enclosure inserts in the right spot. There was one that's a little bit far off from where it's supposed to be, but hopefully I can just drill out the enclosure hole a little bit bigger to make that line up. All the rest are going to be fine. So what we're going to do now is install the batteries into all of the enclosure segments, glue them in, and then we will work on the padding around the outside and around the batteries. So let's get cracking. So we've got our battery here, and just going to start gluing in the cells. And I'm going to put glue in the bottom compartment and then just stick the battery into it. And hopefully that will work out okay. Now that all the batteries have been glued in, we can start putting insulation material on them and then mounting it to the deck. So first I'm going to put some insulation across each of the battery segments, and then I'll put it over each of the balance wire areas, and that will help keep them all in place and keep them from getting rubbed or vibrated apart. After I put some on, we'll bring the deck over and start comparing how it compresses on the deck, and we'll see where else I need to add some. Alright, so I've got my neoprene padding here that I use to put all over the bottom of the battery. And now what I'm doing is cutting out strips that are going to go across the actual connections between each of the segments. And I'm putting it on the deck because I think it'll be easier to align. Otherwise it's going to be almost impossible to see exactly where the screw holes are if they're covered. So I'm going to have to figure that out. But I think I'm going to stick the outside edge on the actual enclosure, and then these in-between pieces I will put on the deck. So I'm just going to keep doing that now. Now comes the tricky part where I have to flip this enclosure over onto this. Not really sure what the best way is to do this, but I'm gonna try and figure it out now. I suppose these should be pretty connected, so maybe I can just do that. Besides the last one. All of the enclosure segments are now temporarily mounted on here, and I've got extra long screws on there which help me align them all properly. And now I need to put in some extra padding along the sides. You can see the large gap on the side here. And then after that, I will get the ESC enclosure like packed in there. And after that, we should be pretty much done. So just a few tiny steps left, and then we'll have a working board. Alright guys, we're basically done. I was going to record a few clips of me shoving everything into the ESC enclosure, but there was no good angle to get it at, and I had to really shove it in there. So I finished off putting all of the padding all the way around the enclosure, screwed everything down, and now we're ready for our first power on. Of course, I did check it before closing it up, because if I had to reopen it, that'd be pretty annoying. So I know it works, but let's power it on right now. So for this particular board, you just press and hold the power button, turns on. You can press and hold the remote and it'll vibrate and turn on. And then you just go. And that sounds pretty great. It's always exciting the first few times you power the board on and it works perfectly. Sometimes it doesn't, but most of the time it does. This is awesome. Let's record a quick outro and stay tuned for the next video where I test this out. The build process for this board has been a great experience, and I hope you guys have enjoyed the entire 4-part series so far. If you agree with me, a like and subscribe would be awesome. But we've got more things on the horizon. The next video, I'll be taking this out on the road, testing it out, and giving some first impressions. Also in that video, I'll be doing a full price breakdown where we go through all the components that I use and how much it might actually cost you to build something like this. Now, I have some moderate expectations for this board. I expect that it'll get around 15 miles with the reused cells. I think it'll be pretty decent acceleration, but not exemplary. And I think that it'll be a pretty good riding experience overall. Obviously, it's not going to compare to anything like a real mountain board with spring trucks and bindings and all that, but it could be a fun off-road carver, and I'm excited to test it out. When I start testing out this board, it will be the first entry on a list of data that I'm going to start accumulating for every board that I test. On this list will be important values like how far you can go in a single charge, how fast the board can actually go, and how fast it can accelerate. With these values, it'll be really interesting to compare all of the different boards that I test. Now, I was kind of inspired to do this by a channel called Skatemetric on YouTube, who used to be super active, but I would love to start something here that is able to compare some of my DIY boards and any other board that I review in the future. Anyways, I hope you guys enjoyed the video, and I'll send you off with a cool video montage. Peace out.